guys, this is Miss Pruitt, and I wanted to make a video for you on u-substitution problems. So let's go ahead and just get started with number 1. In this problem, dy dx equals cosine of 2x. And the question is then, what is y? Well, what I'm going to do is first rewrite this problem by multiplying both sides by dx. And if I do that, I will get dy equals cosine of 2x dx. In order to go from this problem that's derivative to my original problem, I'm going to have to integrate. And I'm going to integrate both sides. Of course, the integral of dy is just y. And now we're left with y equals the integral of cosine of 2x dx. Okay, so at this point, I am ready to try to find the integral. However, I'm noticing that I have a function within another function. And anytime you have a function and a function, you are going to have to use u-substitution. Sometimes it just takes a lot of practice to figure out what right u-substitution to make. In this case, or in most cases, what you want to do is pick the innermost or the inside function. So in this case, my inside function is 2x. So I'm going to set my u to equal 2x. Of course, the next step is to take the derivative. So du equals 2 dx. And I'm okay with this because I do see that I have a substitute for the 2x in my original function, and I do have a substitute for dx. However, this 2 right here does not belong. So I need to move this 2 over to the left-hand side to get another representation for dx. So in this case, I'm going to divide by 2. It is an invisible 1 right here, so I'm going to divide that by 2. So now I'm ready to rewrite my integral. My new integral is going to be 1/2 times the integral of cosine of u du. And I've plugged in my substitutions, so now I'm only working with one function instead of a bunch of multiple functions. This takes care of the chain rule going the derivative route, starting from the original function and taking the derivative. So my next step then, of course, is that this is just 1/2 times the integral of cosine u. Well, the integral of cosine of u is sine of u plus c. And then, of course, you just go ahead and put in your substitutions for u. So I have 1/2 times sine of 2x plus c, and that's my final answer. Okay, so for number 2, it's the integral of, there's a bracket, 9 times x squared plus 3x plus 5, close parentheses, quantity to the 8th power, times 2x plus 3 dx. So if you want to pause it and try it, go ahead. I'm going to pick, again, I have a function within a function, and even though I'm multiplying by another function, I'm going to pick the one that's deepest into the busiest function. I'm going to try to use u-substitution, because if I use u-substitution, I can get rid of all the craziness. So in this case, I'm going to let u equal x squared plus 3x plus 5. Take the derivative. So du will simply equal 2x plus 3 dx. And looky there, I see those substitutes in my original problem. So now all we have to do is rewrite the integral and go ahead and integrate as normal. So in this case, my new integral is just going to be the integral of 9u to the 8th power du. Because of my integration rules, I can pull my 9 out, so it's really, sorry about that. So it's 9 times the integral of u to the 8th power du. And if we go ahead and integrate u to the 8th power, it's just 9 times u to the 9th over 9 plus c. So the answer is just x squared plus 3x plus 5 to the 9th power plus c. Okay, so of course I am going to select my u. In this case, I'm going to pick sine of 3x. And sometimes you do have to play with it. It's only just that, in this case, I know that the derivative of sine will give me cosine. And because sine of 3x is a function within the function inside of this squared function right here, I'm going to try to do or use u with it being sine of 3x. So if we go ahead and take the derivative, du is simply, why am I losing my place? Okay, du, sorry, is cosine of 3x, but just be careful because here we will have to use chain rule. Not only are we taking a derivative of sine, after we take the derivative of the outside function, you have to also take the derivative of the inside function. So the derivative of 3x is 3, right? And then we would have dx. I am good with having a cosine 3x and even my dx on the right-hand side. However, there is no 3 in my original problem, so I have to get rid of it. In order to get rid of it, I need to divide both sides by 1/3. And now it's time for me to rewrite my integral. So you pull out the 1/3 times the integral of u squared du. And then you just integrate it like normal. It's 1/3 times u cubed over 3 plus c. So now I'm ready to just plug in my u. It's simply going to be sine cubed of 3x divided by 9 plus c. Alright, so next problem is the integral of x squared times the 5th root of x cubed minus 2. I'm going to pick my inner function as my u. So I'm just going to pick x cubed minus 2. Take the derivative, and it's 3x squared dx. And I do have an x squared and a dx. I need to get rid of this 3 though. So I'm going to pull my 1/3 out to the front. Sorry if that's difficult to see. So what I'm going to end up having is 1/3 times the integral of u to the 1/5 du, and all I did was rewrite, this is just a side note, to rewrite the 5th root of x or anything is the same thing as x to the 1/5 power. Okay, so in this case, I'm ready to just take the integral as normal. This is just 1/3, and you add 1 to the top and you divide by it. So it would be u to the 6/5 divided by 6/5, but then because we're dividing by a fraction, that means you multiply by the reciprocal. So this will be times 5/6 plus c, actually. So what my final answer would be is 5/18 x cubed minus 2 to the 6/5 plus c. Alright, so for the next one, again, we should be starting to get a hang of this. I'm going to pick u to be 1 minus 2x squared. Go ahead and take the derivative of both sides. You should get negative 4x dx. And if I'm moving that over, I should have negative 1/4 on that side. Rewrite your integral. So I have negative 1 over 4. And because of my integration rules, I can pull out this negative 5. I can pull this negative 5 to the outside of my integral. So this will be times negative 5 times the integral of 1 over u squared du. Well, of course, that's going to be 5/4 times the integral of u to the negative 2 power du, which is going to be 5 over 4 times u to the negative 1 power over negative 1. So, of course, my final answer is going to be negative 5. Oh, my plus c. So, it's going to be negative 5 over 4 times 1 minus 2x squared plus c. All right, here is our next problem. I'm, of course, going to make u be 3t. So du is going to be 3 dt. And I'm going to move this 1/3 over. So my new integral is just simply going to be, I'm going to use my rules to pull the coefficient outside of my integral. So this is simply going to be 1/3 times 5 times the integral of cosecant squared u du. Well, the integral of cosecant squared is negative cotangent. So this would be equal to 5/3 times negative cotangent of u plus c. So my final answer is negative 5/3 cotangent of 3t plus c. All right, you guys, let's do a couple more. With this one, of course, I have a function within a function. I'm going to make my u value be equal to 1/9 x minus 1, which is what's underneath the radical. I'm going to take the derivative. So du is simply just 1/9 dx. To get rid of this, I would divide both sides by 1/9, which actually is the same thing as multiplying by 9. So I'll cross that out and move a 9 on the outside. So now it's time for us to rewrite the integral. So it would be 9 times the integral of u to the 1/2 power du. Then you just take solve the integral as normal. 2/3 u to the 3/2 plus c. And then, of course, reduce. So my final answer would just be 6 times x over 9 minus 1 to the 3/2 power plus c. All right, and last but not least, but this was a special request from earlier today, to do number 14 from the review worksheet. So in this case, I am going to make u equal to what's underneath my radical and go ahead and take the derivative. The derivative, of course, is going to be negative 1 dx. So I'm good with the dx. I'm good with my u, but because my u is equal to 1 minus x. However, there is no negative 1 in the original problem, so you're going to have to divide both sides by negative 1. There's an invisible 1 right there. I'm dividing by negative 1, so 1 divided by negative 1, of course, is negative 1. So now it's time for us to rewrite the integral. As I'm rewriting the integral, I'm just going to write it as this negative 1 on the outside. 1 divided by the square root of u du, which is the same thing as negative times the integral of u to the negative 1/2 power du. And so now let's just integrate like normal. So this is going to be negative u to the 1/2 power divided by 1/2, but dividing by 1/2 is the same thing as multiplying by 2. So then that means it's -2 times u to the 1/2 power. So now I'm ready to back substitute. So it's -2. My u value was 1 minus x, and it's to the 1/2 power. So it's the same thing as the square root of 1 minus x plus c. I guess we should have plus c's up here too. But that's our final answer.